In today's lesson, we are going to discuss the meaning of molecular geometry, and we are going to understand why molecules rearrange themselves in a certain way with a certain angle in the 3D space. We have three learning objectives. First, we need to understand what do you mean by VSEPR theory? Second, what's the electron repulsion magnitude and how does it differ? And last, what do I mean by high electron density regions? VSEPR theory, or valence shell electron pair repulsion theory. First of all, we have to notice that here we are focusing on the last shell electrons, or the valence electrons. So this theory states that like charges will orient themselves in such a way to diminish the repulsion between them by rearranging themselves as far as possible in the 3D space. Now we know that electrons are negative and like charges repel each other, but the magnitude of repulsion is different. For example, the bonded pair of electrons has the least magnitude of repulsion, while if I have a bonded pair versus lone pair, here the magnitude of repulsion is going to be higher. The highest repulsion magnitude is going to be for lone pairs. So if I have a lone pair and another lone pair, they will have the maximum repulsion. Now, to understand the meaning of electron repulsion magnitude, let's take a look at this Lewis structure, which is showing the water molecule. Now, the lone pairs around the oxygen are representing unbonded electrons with unbonded electrons, or lone pair. The repulsion here is going to be the maximum. And then if I'm taking a look at the repulsion between the lone pair of oxygen versus the bonded pair, which is the oxygen and hydrogen bonded pair, here the repulsion magnitude will be less. The least repulsion magnitude will be between the bonded electrons between oxygen and hydrogen. Now, what do we mean by high electron density regions? First of all, we have to remember that we are focusing on the electrons around the central atom of the molecule. So the high electron density regions are representing electrons around the central atom, whether these electrons are bonded electrons or non-bonded electrons known as lone pairs. Now, to understand the idea of high electron density regions, let's investigate these two examples. First, carbon dioxide. Here, the central atom is carbon, and around it, I have two high electron density regions. Notice that I'm considering the double bond as one high electron density region. On the other hand, water and oxygen, as the central atom, has four high electron density regions around it. Oxygen here is surrounded by lone pair 1, lone pair 2, bonded pair 1, bonded pair 2, making a total of 4 high electron density regions. Notice that here we consider the single bond as one high electron density region and each lone pair as high electron density region.